Like with all of our other drugs, alcohol can have tolerance develop as well as dependence. So first we're going to talk about the different types of alcohol tolerance that can occur. We're going to talk about 4 of them. And with all of them, then the effects of alcohol will be greatly diminished with repeated administration. So just like tolerance for everything else, but also keep in mind that we do get this cross-tolerance that develops with other sedative hypnotic drugs, especially the benzos and barbiturates that are also positive allosteric modulators of the GABA A receptor. So what are the different mechanisms that alcohol tolerance can be created, I guess? So first will be acute tolerance. So here, then what happens is, so here we have time administration. Here we've got the blood alcohol or ethanol concentration. And here, then tolerance to the subjective effects of alcohol will develop within a single administration session. So pretty much, if we say take 3 shots, so we take a shot at A, take another shot at an hour later, and then a 3rd shot after 2 hours of being at the party, you're going to start to feel drunk after, say, your 2nd shot. You're like, ooh, I'm feeling it. I'm feeling tipsy. I'm feeling drunk. And so that's what this is saying, is that this is when you're going to start to feel that intoxication. But if we look at the actual blood alcohol content, it's been raising this whole time. And after A administration, so that 1st shot, you're already drunk. And by the time B happens, you're drunk. And what happens is, even though you're not drinking, you're not taking another shot, we can see here that your blood alcohol content is continuing to rise, because it does take a while for the alcohol to pass through your system and absorb from both the stomach and the small intestines. So even when we take our 3rd shot and we stop drinking, then our blood alcohol content continues to rise, and it stays pretty high for a while. Now, what acute tolerance is saying is that even though our blood alcohol content is so high here, after a few hours, you're going to start to feel sober. So you don't feel those effects of alcohol. You don't, maybe you're not dizzy when you stand up. You feel like you can think straight. You're not nauseous anymore, things like that. But if we were to take your blood alcohol content, again, we would see that you're still drunk. You're legally drunk still, even though it's been a few hours and you feel sober. And so this is the acute tolerance. So it's within one single administration session, tolerance can occur. Okay? Next, we've got metabolic tolerance. And you can probably guess what this is about. This is tolerance that develops having to do with the enzymes that break down alcohol. So what's going to happen is we're going to have an increase of these liver enzymes like ADH and P450. And therefore, you're going to start to need more alcohol over time to maintain the amount of drunkenness, whatever, that you needed before. Okay? Now, it can actually occur pretty quickly, pretty short, time period. After just 7 days, so, if you, drank a lot for 7 days, after 7 days, you're going to see metabolic tolerance. So, you got to be careful there. Next, we've got pharmacodynamic tolerance. So these are our adaptive changes in response to chronic alcohol consumption. And this is where we see changes in the receptor expression. So we've already talked about an increase in NMDA receptors, which leads to an increase in glutamate release. What also happens is we see decreased GABA receptor function. Um, we just do. And then we also see decreased synthesis and release of opioids and decreased firing of the mesolimbic dopamine neurons. And all of this is happening to try to rebalance out your system, right? Because remember, alcohol blocks the NMDA receptor, so it's going to increase those so we can still have them. It activates the GABA receptor, so we're going to decrease the amount of GABA function to get back to normal. It naturally increases or acts like an opioid, so we're going to decrease the synthesis of our opioids to get back to that homeostasis. Then we've got our behavioral tolerances. Now, classical conditioning can happen here for our behavioral tolerance, very similar to the opiates. So like that example or that question that we had in midterm 2 about how behavioral tolerance can lead to overdoses with opiates, we've got these environmental cues that tell the body when to get ready to prepare, because you're going to take a drug, in this case alcohol, and your body's going to prepare for it. And so if you take a alcohol in a different situation, your body's not going to be prepared, and so you're not going to have those compensatory changes in place. So you're going to actually get more drunk in a different place than if you always drink at a certain bar or something. In rodent models, then alcohol administration actually decreases the body temperature. So these are, again, those compensatory changes because the body, after chronic administration, knows that alcohol increases body temperature. So it's going to preemptively decrease body temperature so that once you have the alcohol, you'll be back at a homeostasis. And this may actually play a role in why some people crave alcohol in certain situations. Because remember, with classical conditioning, an environmental cue doesn't have to be a place. It could be like a group of friends. It could be like a party environment, things like that, or a stressful environment. It doesn't have to necessarily be a specific place. Then, of course, we've got behavioral changes that occur with behavioral tolerance. So these are practicing behaviors under the influence actually leads to improved performance. So some people say, oh, like I can drive while drinking because I'm really good at it. And it's really just that they've driven while drunk so many times that they're better at it, but they're still never going to be the same amount that they would be sober. Okay? So it doesn't matter how many times you've driven drunk, you're never going to be as good of a driver as you would be sober. So never drink and drive. There's an example here with rats. And then these behavioral changes are things we see very commonly in high-functioning alcoholics, is they are so used to being drunk while doing behaviors that now they can do those behaviors just as well or almost just as well as if they were sober. Now, how do these tolerances develop? Very quickly. Very quickly. Within a few weeks, sometimes within within a week. And then, of course, those acute tolerances occur within a single session, so just a few hours. It is reversible. Tolerance does diminish after 2 to 3 weeks of abstinence. So, if you used to go out all the time with your friends after school, and then COVID hit and you didn't get to, and you just sat at home and you didn't drink at home, your tolerance isn't going to be as high as it was before. And that can be dangerous. Now, repeated exposure, so like if people go on binges and stuff, it actually leads to a more rapid development of tolerance. So if you like binge for a week and then abstain for 2-3 weeks and then binge for another week, that kind of thing, then every time you binge, your tolerance is going to develop more quickly. Obviously, I'm not saying binge, but I'm just explaining how it works. Now, Along with tolerance, we've got dependence. So prolonged intoxication can result in adaptive changes. So these are the mechanisms of tolerance, especially pharmacodynamics, can actually lead to this physical dependence on alcohol. And that's because your body's trying to restore that homeostasis the whole time. Now, physical dependence can also be demonstrated very easily just when looking at people that are going through withdrawal of alcohol. These withdrawal symptoms begin as early as just a few hours. This is what we usually call a hangover, but a hangover is withdrawal from alcohol, okay? Just at kind of a smaller scale. So this acute withdrawal or a hangover, we've got these symptoms. I'm sure a lot of you know about them. We've got nausea, headache, dry mouth. Hangover is often, again, described as the early components of a withdrawal. So maybe because of an acute tolerance rather than dependence, but it is thought of as a type of withdrawal. Alternatively, then it's considered to be signs of acute toxicity from alcohol and metabolites. So it's actually thought to be your body recovering from a poisoning. So some people say it's one or the other. I kind of think it's both. But that's kind of what a hangover is. Again, if you just drink a lot more water while drinking, you can avoid a hangover if you're drinking acutely. So what contributes to this hangover? Here, dehydration. That's the one I talked about. Really, just guys, drink water. Drink water. Hangovers can vary between individuals. It can also vary depending on different times you drink. You know, I've had hangovers where some of this, I get dehydration and nausea and stuff, and sometimes I don't. It really varies. Again, a hangover generally occurs after a single session. Possible multiple causes we kind of talked about, including toxicity. So this is that accumulation of acetaldehyde for these toxicity effects, which can include nausea, vomiting, and headache. So we talked about that back then. And then we've got some rebound effects on our blood sugar. So this is like faintness, fatigue. This is why people love to go out and eat afterwards, because they've got this fatigue. You know, they feel nauseous, but they really need that like greasy good stuff afterwards. Now, things that can help contribute to it would be ingredients or fermentation byproducts that actually exacerbate conditions. So red wine, some people say red wine has the worst hangover, and that's because it contains tannins and sulfates. Now, you can get things that take these out of your red wine, and that would actually help reduce your hangover effects. And then some people get hangovers worse with distilled spirits than with, say, beer or wine or a cooler, and that's because of the methanol that is in distilled spirits. Distilled spirits doesn't have just ethanol. Okay? Now, what about in other, like, withdrawal from chronic use? So say someone is an alcoholic and they're like, I'm not going to be an alcoholic anymore. They're going to have to go through withdrawal. And so now when we're talking about early withdrawal and late withdrawal, then we're talking about withdrawal from chronic use. So early withdrawal will be from 8 to 12 hours after the last drink. And here we're going to see some kind of typical withdrawal symptoms that we've seen before with agitation, tremors, nausea, sweating. Here we get that rebound effect with the REM sleep, so vivid dreams. This lasts for about 2 days. It is the less severe component of alcohol withdrawal. So the first 2 days is actually less severe withdrawal than late withdrawal. Now, fewer than 5% of patients hospitalized for alcohol withdrawal go on to develop late stages of withdrawal. Okay, so a lot of people will go through withdrawal for chronic use and only experience early withdrawal. So, what are the rebound effects? So, looking at the GABA A receptor, then we know that alcohol enhances GABA A function. So, what happens with rebound is that we get the GABA A receptor function decreases. So, what that means is that we get the hyperexcitability. So, here we'll see tremors and seizures because we don't have that GABA to control the glutamate. Looking at the NMDA receptor, again, alcohol normally inhibits NMDA. So what's going to happen is the NMDA receptor is going to now increase. So we're going to get a lot of glutamate release now. So our rebound effects lead to hyperexcitability. Again, we're going to see seizures, glutamate excitotoxicity, and hallucinations. So you can see that the rebound effects for GABA A and NMDA are pretty similar. Both cases, you can get seizures. And then here I said hallucinations, and that's going to lead us to these late withdrawals. So late withdrawal can be contributed to this thing called delirium tremens, or DT. So delirium tremens comes from Latin meaning shaking frenzy, which really explains this whole thing. So the onset's about 2 days after your last dose, and it can last for over a week. What we see is that patients that do develop this, again, remember it's less than 5%, experience tremors and seizures and vivid hallucinatory episodes. There's this fun picture. They talk about the pink elephant. People don't actually see pink elephants, usually in hallucinations. It usually involves smaller animals like bats and rats and insects. So if you want to know what animal you'll see during a late withdrawal, not an elephant. But these hallucinations are often very terrifying. People can't recognize what's real, what's not, and it's very scary to go through. There are, of course, very severe risks with DTs. Like I mentioned, those early withdrawal symptoms, those are not bad ones. The bad ones are the late withdrawal symptoms. And that's because we get altered GABA homeostasis, which leads to unopposed sympathetic activation. By now, you know what that sympathetic nervous system activation can lead to. We see excitotoxicity, so this is irreversible brain damage, seizures, coma, and in order to kind of treat this, then management of DT does involve administration of benzos because of its cross-tolerance at that GABA A receptor. So it's thought to help minimize some of the effects of the GABA. It can help treat those seizures and lessen the severity of these late withdrawal effects.